Let's create a design and simulate a thermoelectric heat generator example. So for that, let's start the design from here. So let's define multiple layers. So let's have this layer 1, layer 2, 3, 4, 5. So I'll read it as it is. Just change the color. Click OK. So let me start from layer 1. That's the bottommost layer. So I select a rectangle. So I enter these coordinates 0, 0 and then 120, 50. A rectangle is created. Above this, let's create one more rectangle. 0, 0, 50, 50. Another rectangle in the same layer. So let's create that. 70, 0. Then 120, 50. So let's have one more about this. Repeat. Same thing. 0, 0, 50, 50. So another rectangle in the same plane. So we have 70, 0. We have 120, 50. So layer 4, we repeat the same rectangle what we did the layer 1. So 0, 0, 120, 50. So let's draw final layer. So minus 20, 0, 140, 50. So we have created a geometry with 5 layers. Once the design is created on Blueprint, so let's import this file. We assign different material entities. So let's starting from here. So let's split this into two because we require an isolation layer. So hence we'll define this to be 5 micrometer and then this as 5 micrometer. So we have in total we define these heights. Is 5 and this is 50. So here we require to change this entity. All are all are different entities, so no matching colors anywhere. So let's save this file. Once the model opens up on thermal electromechanical, we set the simulation settings. Seeback, apply, OK. We define the material properties. One by one. That's a conductor, so we assign copper. Same is the case for material 3 as well. So here this material, what we see, is not available in the database. So hence we can edit this. So we go to, so this is the n type. So we have these values that we feed in. So for future use, if we require these material database which are not there, so we edit these things and then we can export it and we can save the file. Okay. So for future use. So let's move on with the next material. So this is a p-type material, so density remains the same, but uh, it's only the Seeback potential will change. So now let's again go to the layer and let's define copper. And the isolation layer. So since it's isolation, so let's increase the resistivity value. So any value which is beyond 1 exponential 6 is treated as isolation layer. Okay. So hence we define the resistivity value of this particular entity as 1 exponential 7. And then finally we have silicon again, silicon 100. So we are done with the material properties. So just save this file. So let's define the loads. We go to voltage, entity, phase. So on this side we set 0 volts, and then we go to load, current, phase 28, E minus 6. So we require heat connection to be defined. So this gives some values um, on the top. So we don't have to define any boundary conditions, fixed boundary conditions here. So we can directly go to mesh. We can define 10, and then we can run the simulation. So let's save this file, then run the simulation. Okay, so simulation is completed. So let's look at the results. So we see potential, we see temperature, so we see the electric field distribution here.